Welcome back to the Solutions Lab. We're going to be looking at problem number 23, which is taken from your course pack, exercise 6.2 in Module 9. This question involves a weather balloon and the determination of the distance between 2 points of observation. Now, one of the trickiest parts about this question is getting your diagram correct. So we have a weather balloon somewhere floating high above us and 2 points of observation, and those points of observation are 10 kilometers apart. So let me just show the distance between the 2 places where observations are being taken in red. So observation point 1 and observation point 2 are 10 kilometers apart. Okay. And we also know that there's an angle of elevation from those 2 points of observation. So from observation location 1, the angle of elevation looking directly up to the weather balloon is 78.17 degrees. So 78.17 degrees is the angle of elevation when you're looking from observation point 1. Now 10 kilometers away at observation point 2, the angle of elevation has decreased considerably, and it is now 17.83 degrees. So you can see my drawing isn't super accurate, but you get the idea. The further away the observation point, the more acute or smaller the angle of elevation becomes. And the thing that we're trying to find is the height of that the balloon is from the ground. So that is what we are wanting to find. Looking at our diagram, we can see 2 right-angled triangles. This triangle with a angle of elevation of 78.17 shown up above in blue has an opposite side of length h, the variable we're trying to find, and an adjacent side of length x, which we don't know. There's also a second triangle which runs with these boundaries, and I'm showing that above here in red, and it also has an opposite side of h, the unknown variable, and its adjacent side we know to be 10 kilometers more than the adjacent side of the blue triangle. So its adjacent side is x plus 10 kilometers. And as we said before, the angle of elevation is 17.83. So if we look at the first triangle, blue triangle, we can say that the tan of 78.17 is equal to the opposite side, h, divided by the adjacent side, x. And we can also say that h, therefore, is equal to tan of 78.17 times x. Now if we look at the second triangle, similarly, we can say the tan of 17.83 is equal to the opposite side over the adjacent side. And we can also say that h is equal to the tan of 17.83 times x plus 10. Now since h is equal to this expression and h is also equal to this expression, we can say that this expression is equal to this expression. Tan of 78.17 times x is equal to tan of 17.83 times x plus 10. Now, entering the values of the angles into your calculator, you'll obtain for tan of 78.17 4.774 times x equals, and tan of 17.83 is equal to 0.3217 times x plus 10. So substituting the values of the angles into your calculator and obtaining the tan ratios, we end up with a simplified equation to solve. 4.774x is equal to 0.3217 times x plus 10. So our first step in solving this equation will be to use the distributive law to deal with the brackets. So we end up with 4.774x is equal to 0.3217x plus 10 times 0.3217, which is 3.217. Next, we'll use the addition principle. We'll want to move this x term over to the left-hand side so that we can collect like terms. So we'll subtract 0.3217x from both sides of the equation. Subtracting from this side removes it, and then if we subtract 4.774 minus 0.3217, we obtain 4.4523x is equal to 3.217. So we can now solve for x. We divide by the coefficient using the multiplication principle from Module 3 and obtain x is equal to 0.7225. Now finally, at this stage, we can actually determine h, the variable we've been looking for, since h is equal to the tan of 78.17 times x, and we now know what x is. So h is equal to the tan of 78.17, which we've determined earlier was a value of 4.774, times x gives us a value for h of approximately 3.4.